Hello and welcome to today's VMware webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there is no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now I'd like to turn things over to today's presenter to get things started.
Good morning, everyone, and welcome to VMware and Amazon Web Services webinar on streamlining business-critical Oracle workloads on VMware Cloud for AWS. My name is Andrew Nielsen. I'm the Senior Director for Workload and Technical Marketing here at VMware, and I'm also joined today by Sudhir Balasubrahmanian, who's a Staff Solution Architect for Oracle, and from AWS, we have Jay Sampath Kumar, who is an AWS Oracle Solution Architect. Today, as we discuss Oracle on VMware Cloud on AWS, we'll start with a brief introduction on VMware Cloud on AWS, and then I'll hand it over to Sudhir, who will talk about Oracle running on VMware Cloud on AWS, and then we'll turn it over to Jay to talk about integrating Native AWS Services, go through some final thoughts, and open this up for questions. So let's get right into it. As we look at VMware Cloud on AWS, this is really about deploying applications and solutions into the cloud. And as we look at applications now, in the next 5 years, we will deploy more applications and solutions than mankind has deployed in the last 40 years. But these applications are no longer your traditional N-tier applications. These applications are driving advanced analytics. They're focused on industrial IoT, their data-defined business process, as well as process automation, and driving self-service experiences. In order to embrace these applications, you need a platform that has global reach. And that is what VMware Cloud on AWS provides you. Let's jump in and look at what VMware Cloud on AWS is. This is really the marriage of the #1 private software-defined data center provider with the #1 public cloud provider of global infrastructure between VMware and AWS. And VMware Cloud on AWS allows you to rapidly extend to the cloud anywhere in the world. It gives you operational consistency and security consistency in that everything that you've done on-premise with your VMware environment can automatically go straight to the cloud. And more importantly, it gives you access to native AWS services that you know well, like EC2 or S3 or RDS, and Jay will touch a little bit more about that later in our presentation today. Looking at the overall global architecture, by the end of this year, anywhere that there is an EC2 instance in AWS's network, there will be a VMware Cloud on AWS instance there, except for mainland China. So depending on what your data gravity requirements are or where you would like to run your applications, we are there to support you. But, no discussion about cloud would be complete without talking about cloud economics. And VMware Cloud on AWS gives a cloud economics model for the modern enterprise in that there is no rework. So all of your workloads that are running on VMware in your data center today can be immediately vMotioned to your cloud, giving you zero rework. There's no refactoring, there's no replatforming. It's a consistent infrastructure from your data center to the cloud, giving you a true hybrid cloud experience. There's also no reskilling required. So all of your VMware experience that you have running in your data center immediately transfers to your cloud experience. There's no workload lock-in. So you have workload portability in the sense that you pick up your workload, you move it to VMC on AWS. As an example, we have customers who will actually move their applications back to the data center to do upgrades or other maintenance tasks, and then vMotion it right back to VMC on AWS in the cloud. So you have that portability with zero lock-in. And there's really no repayment anymore. If you don't have to do infrastructure upgrades anymore, you can really move from a traditional CapEx to an OpEx model from a cloud perspective and focus on your workloads and applications rather than worry about maintaining your own physical infrastructure. We focus very much today on customer-driven use cases, and there are 4 key ones that we talk about. One is data center extension, where we have customers who will extend their data center into the cloud for on-demand capacity. Maybe they want to move their test and dev environments from a CapEx to an OpEx expense, as well as virtual desktops for maybe seasonal workers or for training or use cases like that. Disaster recovery is also another use case that we see a lot of. So for customers who are going to great expense to maintain 2 separate physical environments for DR, we give you the ability to move that to an as-a-service experience, as well as an OpEx model. So you can either stand up new DR that you may or may not have. Maybe you're replacing your existing DR solution that's in need of a hardware refresh, or you're complementing an existing DR solution that you may already have in place today. From there, we move to cloud migrations, and that can be everything from a data center evacuation to where you're actually, maybe you're at the end of a lease in a data center and you're moving everything out, or you just want to move specific applications, or maybe the entire data center. And last but by no means least, next generation apps. And one of the beauties of the VMware Cloud on AWS partnership is that your workloads, as they move into VMC on AWS, can now get access to native AWS services that you otherwise would not have had access to in your data center. So we have a variety of customer references, as you can see on the bottom there. You can find more information about that on our website. Now with that, I'm going to transfer this over to Sudhir Balasamaranian, and he will walk you through Oracle on VMware Cloud on AWS. Sudhir, the floor is yours.
Thank you, Andrew. So now let's take a look at how we can deploy and migrate Oracle workloads onto VMware Cloud on AWS. So as we have seen in the earlier slides, some of the use cases for VMware Cloud on AWS, they are data center extension, disaster recovery, cloud migrations, next generation apps, and Andrew touched on that as well. So now let's take a look at some of the advantages of using VMware Cloud on AWS for business critical Oracle workloads, namely simplified migrations, accelerated provisioning, application modernization, etc. Simplified migration. So as we know, VMware Cloud on AWS is powered by VMware Cloud Foundation, and this service integrates vSphere, vSAN, and NSX along with VMware vCenter management. Well, owing to the fact that the underlying VMware stack is the same on both on-premises and on VMware Cloud on AWS, this essentially ensures a seamless, low-risk migration of Oracle workloads from on-premises to VMware Cloud on AWS and back, because there is absolutely no VM conversions, there is no application refactoring, and hence there is no application downtime. There is no networking changes, provided there is an L2 VPN or Layer 2 VPN capability between the on-premises SDDC and VMware Cloud on AWS. See, these are key, as some cloud providers, they require some level of refactoring to achieve the above, which is not the case here. Thereby, we save a lot of time, we save a lot of effort, save a lot of man hours to try to plan migrations between on-prem and the cloud. The migration from on-premises to VMware Cloud on AWS and back is actually orchestrated using a suite of well-known Oracle and vSphere native tools. For example, VMware HCX, Enhanced vMotion, Oracle Data Guard, Oracle Armin, and so on and so forth. See, another use case is to send database backups to VMware Cloud on AWS, or even use it as a disaster recovery target. Last but not the least, owing to the fact that shared storage and layer 2 multicasting is offered natively on the VMware platform without using any third-party software, even Oracle RAC can be easily deployed on VMware Cloud on AWS. With these stretch clusters for VMware Cloud on AWS, one can achieve 3 levels of high availability, namely site level using multi-AZ or multi-availability zones, infrastructure level simply by leveraging the VMware HA stack, the capability, and application level HA using Oracle RAC. Accelerated provisioning. With VMware Cloud on AWS, we can now provision an entire VMware SDDC within a few hours as compared to the days it traditionally used to take in procuring a server, racking it, stacking it, installing ESXi, and so on and so forth, and the rest of the steps. So we can now add AWS EC2 bare metal servers to the cluster on demand based on the customer need, and hence are able to scale horizontally, effortlessly, hereby meeting the business SLAs and demands. There is no more over-provisioning or complex demand forecasting. Typically, this is found in customer deployments where one has to over-provision infrastructure, over-provision resources in advance, given the fact it's time-taking to get new hardware, and this actually reduces cost. VM operations are now streamlined the same way as you would streamline it on premises using VMware automation tools like PowerCLI, APIs, or even Puppet and Shift. Application modernization. So with VMware Cloud on AWS, we are now able to leverage native AWS services. So for example, Amazon Simple Storage Service, Amazon S3 for Oracle backups. We are now able to provide modern capabilities to legacy applications and thereby making them more robust. You make them more modern, scalability, and able to meet the business demands. So one can now use AWS Lambda, which is basically a serverless framework in conjunction with Oracle workloads on VMware Cloud on AWS. We can also extract data out of Oracle workloads and leverage analytic services. For example, the AWS Redshift, the Athena, Kinesis, QuickSight. So these are some of the Oracle solutions which can be deployed on VMware Cloud on AWS. The resources page at the end of the slide deck basically has all of the requisite links. Now let's look at deploying Oracle RAC workloads on VMware Cloud on AWS. So with VMware Cloud on AWS, ESXi hosts, they traditionally reside in an AWS AZ or availability zone, and they are protected by vSphere HA. Now, deploying Oracle RAC on VMware cluster provides application level HA in addition to the infrastructure level HA provided by the VMware HA. Steps to deploy an Oracle RAC and VMware Cloud on AWS is exactly the same as one would do on premises. See, the only subtle difference here is the creation of a logical network for the Oracle RAC private interconnect on VMware Cloud on AWS as opposed to creating a dedicated distributed port group on premises. So the network section shown in the slide here that shows an Oracle private logical network, which is created for the Oracle RAC private interconnect traffic. And rest of the steps from a provisioning perspective, from a compute perspective, or even the storage perspective is no different than deploying an Oracle RAC on premises. Essentially, please refer to the Oracle database on VMware Best Practices Guide, which provides best practice guidelines for deploying Oracle workloads on VMware SDDC, and the Oracle RAC VMware deployment guide, which basically describes the deployment of an Oracle RAC using ASM library on VMware vSphere platform for Oracle DBAs who are planning to virtualize Oracle RAC on VMware platform. Now, let's look at deploying extended Oracle RAC on stretch clusters for VMware Cloud on AWS. So with VMware Cloud on AWS, as mentioned before, ESXi hosts by default, they reside in a single AWS availability zone, and they are protected by vSphere high availability, the vSphere HA. So now, a feature called stretch clusters for VMware Cloud on AWS, that is designed to protect against an AWS AZ failure. The applications can now span multiple AWS AZs within a VMware Cloud on AWS cluster. So the vSAN fault domains are configured to inform vSphere and vCenter instances which host resides in which AZs. And actually, to increase clarity, each fault domain is basically named after the AZ it resides within. The extended Oracle rack, it actually provides greater availability than the local Oracle rack. It provides extremely fast recovery from a site failure. It enables all servers in the site to actively process transactions as part of a single database cluster. Now, running extended Oracle rack on stretch clusters for VMware Cloud on AWS provides the same advantage as running the traditional Oracle rack across data centers and sites, in addition to the AWS AZ level protection that the stretch clusters for VMware Cloud on AWS provides. See, an important aspect of any Oracle rack configuration on VMware SDDC setup is basically to ensure that the Oracle rack virtual machines are not scheduled on the same physical ESXi server, because that basically negates the HA proposition that VMware SDDC has to offer. That is the infrastructure level HA provided by the VMware SDDC to complement the application level HA provided by Oracle rack. So in order to achieve that, we need to specify virtual machine anti-affinity rules for Oracle rack virtual machines, which essentially forces the rack VMs to remain apart during failover actions. So in case of an extended Oracle rack across multiple sites or multiple AZs, the best practice is to spread the Oracle rack VMs across multiple sites to ensure HA across the sites, in addition to the infrastructure level HA and the application level HA, which ensures all rack VMs do not land on the same site at the same time. So this is basically achieved using compute policies, tags, and attributes, which allows us to attach metadata to objects in the vSphere inventory. Deploying and migrating Oracle workloads from on-premises to VMware Cloud on AWS, that has been documented in detail in a reference architecture document, which is provided in the resources page at the end of the slide deck. Now, let's take a look at migrating Oracle workloads to VMware Cloud on AWS. Right. On a very high level, the Oracle workload migration from on-premises to VMware Cloud on AWS, it can be achieved in one of the two ways. So the first option or the first way is using native VMware and Oracle methods. The second way is to use VMware HCX, aka Hybrid Cloud Extension. So in this section, we will use native VMware and Oracle methods to migrate rack and non-rack workloads to VMware Cloud on AWS. So let's take a look at the example setup shown in the architecture here, right? So basically, it's a 3-site lab setup that includes the on-premises site A, it has a site B, and then it has connectivity from site A to VMware Cloud on AWS. So on site A, the on-premises vSphere cluster is running production workloads. Site B basically runs the dev, the test, and also the disaster recovery workloads. Both site A and site B, they are in a hybrid link mode. Site A and site B vSphere clusters, they have access to their own dedicated storage, so they're not sharing storage. Site A is connected via layer 2 VPN to VMware Cloud on AWS. And the VMware Cloud on AWS essentially is in a stretch cluster deployment. That is, it's a 6-node stretch cluster for VMware Cloud on AWS across 2 availability zones, 3 servers in AZ1, 3 servers in AZ2, and the storage in VMware Cloud on AWS is provided by the HCI vSAN instance. So the current solution designed and deployed 3 separate environments. So basically in Site A, you had a 2-node Oracle rack. As we can see here, it's PRD rack comprising of 2 Oracle rack virtual machines, rack 1 and rack 2. Site A also had the Oracle FarSync PRDFS. The name of the virtual machine is PRDFS. And Site B essentially hosted a 2-node Oracle rack for disaster recovery purposes called PRDDG. Now, Oracle rack on premises, it requires the shared VMD case to be deployed with the multi-writer attribute, and it has to be provisioned as eager 0 thick as per KB article 212.1181. The current restriction of the multi-writer attribute is to disallow storage vMotion. Right. So let's take a look at how we can migrate a single instance Oracle workload to VMware Cloud on AWS. So in this section, a single instance Oracle VM on premises that is successfully migrated to VMware Cloud on AWS transparently in a couple of mouse clicks. The virtual machine is running Oracle Enterprise Linux 7.4 operating system, Oracle 12.2 grid infrastructure, and RDBMS binaries. Oracle ASM disks are created using the Oracle 12.2 ASM filter driver, ASM FD, and then we use the multi-tenant option running a pluggable database, PDB1. So by following the mentioned steps shown in the slide here, wherein we choose the migration method, we choose the resource pool, we choose the storage, we choose the destination network port group, one can seamlessly and transparently migrate the single instance workload to VMware Cloud on AWS. Now, coming back to the Oracle RAC discussion, right? So essentially, Oracle RAC virtual machines, they have two types of VMDKs. So one is the non-shared, non-database VMDKs that essentially houses the operating system disk, the Oracle binaries, essentially the grid infrastructure, and RDBMS. And the second kind of VMDKs are the shared eager zero-tick VMDKs that uses multi-writer attribute. So as I've already mentioned before, there are certain limitations using the multi-writer attribute found in KB article 212.1181 that essentially disallows storage vMotion of shared VMDKs using the multi-writer flag. So essentially storage vMotion migration is disallowed. So if one has to migrate an Oracle RAC from on-premises to VMware Cloud on AWS, essentially the high-level steps would be to shut down the Oracle RAC. We power off VM1 and VM2. On the virtual machine 2, you would remove the shared eager zero-tick VMDKs, and you would storage vMotion VM2 to VMware Cloud on AWS. On VM1, you would again remove the multi-writer flag from the eager zero-tick VMDKs, storage vMotion VM1 to the VMware Cloud on AWS. What happens is once it lands on vSAN, the eager zero-tick VMDKs are converted to lazy zero-tick. So essentially, now you would add new eager zero-tick VMDKs with multi-writer flag, same size as lazy zero-tick VMDKs, start up VM1, use the Oracle ASM to add and drop disks. You would drop VM1 lazy zero-tick VMDKs, the older ones, and on VM2, do the same thing, essentially add the VM1 new eager zero-tick VMDKs with multi-writer flag at the same SCSI position, and essentially start the Oracle RAC up. So let's change gears and talk about how we can use VMware's HCX tool to migrate Oracle workloads from on-premises to VMware Cloud on AWS, right? So this section essentially addresses the second way of migrating the Oracle workloads. So again, this is the same three-site lab setup. This includes the on-premises site A, the on-premises site B. It includes the connectivity to the VMware Cloud on AWS. Site B is connected via HCX or hybrid cloud extension to VMware Cloud on AWS. So the HCX pairing is configured between site B and VMware Cloud on AWS with bidirectional migration between on-premises and VMware Cloud on AWS. All right. So this section essentially talks about how the different ways of migrating Oracle workloads using HCX. See, what happens is with this approach, VMware HCX, it abstracts on-premises versus cloud notions, and it presents the capability to virtual machines as a continuous hybrid cloud, hence providing minimal operational overhead without requiring a retrofit of legacy infrastructure. So essentially, there are four types of HCX-enabled migrations. Cold migration, where it integrates with VMware NFC, network file copy, and uses the same network path as HCX vMotion to transfer a powered-off virtual machine. So during a cold migration, the VM IP address and the MAC address are preserved. Cold migration must satisfy the vMotion requirement. The second way of doing it is the HCX bulk migration, which essentially uses the host-based replication to move a live VM to and from HCX-enabled cloud sites or data centers. To reduce the downtime, the source VM remains online during the replication and is essentially bootstrapped on the destination ESXi host after the replication completes. The third way of doing it is the hot migration, where VMware HCX vMotion, which is basically the enhanced vMotion, that can transfer a live VM from an HCX-enabled vCenter server to an HCX-enabled remote site or from an HCX-enabled target site towards the local site. So the vMotion transfer, it captures the VM's active memory. It captures its execution state, its IP address, and also its MAC address. So migration duration, it essentially depends upon the connectivity, that is the bandwidth available for the HCX migration, and also the latency between the two sites. So some current restrictions with HCX vMotion currently, VMs with the following attributes are not supported for HCX vMotion migration. If you have shared VMDKs, well, that is the use case for Oracle RAC, or if you have disk size that exceeds 2 terabytes. The final one, the fourth way of migrating is the HCX vMotion with vSphere replication. Essentially, it's called the HCX RAV, or the Replication Assisted vMotion. This is the new migration method that combines the benefit of both HCX bulk migration, that is, parallel operations, the resiliency and the scheduling, with the HCX vMotion, which is essentially zero-time VM state migration. So migration begins with the replication of the virtual machine disk, as is true for the bulk migration. Virtual machines can be moved in parallel with the switchover configurable on a schedule. Now, during the RAV, or the Replication Assisted vMotion switchover phase, vMotion is engaged for migrating the disk delta data and the virtual machine state. So as mentioned before, VMware vSphere storage vMotion is disallowed when using Oracle RAC with shared VMDKs and multi-NAT flag. Replication of virtual machines that shared VMDKs are currently not supported in vSphere replication, and essentially Oracle RAC migration using HCX or storage vMotion is currently unsupported. All right. So changing gears a bit and talking a bit about Oracle licensing. So when we talk about VMware Cloud on AWS, when we talk about vSphere, vSAN, VxRack, or VxRail, essentially the Oracle licensing does not change from a licensing perspective, whether one runs Oracle workloads on a classic vSphere environment connected to a SAN or a NAS, or a hyperconverged infrastructure solution, for example, vSAN, VxRail, VxRack, or even on VMware Cloud on AWS, or for the sake of discussion, Flex clusters for VMware Cloud on AWS. So there are three and only three legally binding documents that are relevant for any Oracle licensing discussion, and those three documents are the technical support statement, the core processing factor table that essentially assigns every core or every processor a core factor that entails or that helps during the calculation of the Oracle licensing, and the OLSA, or the Oracle Licensing and Service Agreement, aka the Oracle Master Agreement. So at the slide, you can see a lot of links. There are a lot of links in the blog sites. Please have a look at it for further details. Couple of facts when we talk about Oracle licensing and we talk about running Oracle workloads on VMware Cloud on AWS. So at initial availability, dedicated SDDC cluster for Oracle, essentially we had no choice but to license effectively all cores for all hosts in the SDDC cluster. Keep in mind, when this solution was first came out, we had to take into account even now the maintenance, the retirement, and the failed host, the hardware host replacement. And essentially that's described in the blog article there. September 6th of last year, right, when we released SDDC version 1.5, we came up with what's called the compute policy. So that essentially allowed us to come up with simple virtual machine to host affinity rules. Keep in mind that these affinity rules are preferential policies at the SDDC level. So they operate by leveraging the inventory tags. And the most important thing is the preferential policies that cannot block a host from entering into a maintenance mode. And that is an essential potential Oracle licensing violation. So to fix it this year, what we came up with, or essentially last year, what we came up with was, we came up with a minimum 3 hosts and a maximum 16 hosts per SDDC. So essentially we reduced the number of servers per SDDC cluster. So that was as of September 10th of last year. And this year, February 12th, 2019, with SDDC versions 1.6, we came up with a feature what's called a custom CPU core count, right? And this is true for the second cluster onwards. So essentially, when one goes to deploy a second SDDC cluster for the Oracle workloads, one has a choice for i3 servers to go as low as 8 cores or 16 cores or 36 cores per i3 server. And if one were to deploy an R5, a cluster with R5 servers, one has an option of going either with 8, 16, or 48 cores per server. So one no longer has to go with the initial availability, when we came out, we provided 2-socket 18 cores each. So one doesn't have to go with 36 core per server. One has an option for i3 to go as low as 8 cores per server. So reduce number of cores per server and lesser number of servers per SDDC cluster, right? We release those features in hope that will help with the Oracle licensing discussion. So over to you, Jay.
Thanks, Sudhir, for that talk. Let's see in this section how you can integrate your Oracle workloads with native AWS services. Just to explain what this native AWS services means. Native AWS services are like EC2, your RDS, S3 services. We have 160 plus services, and we keep adding new services every month. And VMware Cloud on AWS is a tightly engineered solution on AWS. We had both the teams from AWS and VMware working on this solution so that VMware VMs has got access to the same level of services like a native EC2 VMs. So if you're running any workload on VMware, whether it's an Oracle database or a tech stack like Oracle WebLogic, Web Center, or even like business critical applications like eBusiness Suite, PeopleSoft, Hyperion, you have access to the same level of services for these workloads. For example, Oracle RAC customers use Route 53 and Amazon Simple AD services as part of configuring their DNS resolution. Oracle eBusiness Suite customers running on VMware Cloud on AWS use Elastic Load Balancers to load balance between two or three of their WebLogic clusters. And almost all the customers use Orman backups. And the way we have seen customers taking Orman backups is they use Amazon S3 as your backup storage and S3 Glacier as your long-term archival storage for their Orman backups. Just to highlight a few services which we have seen customers commonly use with their Oracle workloads. For backups, we have Amazon Simple Storage Services, S3, and Amazon S3 Glacier, which helps in long-term archival storage if you want to preserve the backup in a 7 or 10 years time frame. And you have AWS Storage Gateway, which mounts these S3 bucket and S3 Glacier into a simple NFS mount point in your VMware VMs. And for security, we have seen customers use key management services or KMS to store their security keys, and AWS Shield to provide a DDoS protection for their web servers, and AWS Secrets Manager to store their username passwords so that you can programmatically retrieve for your scripts and automation. Other things like Amazon Simple Notification Service, which can send notification via text, email, which is quite popular when you write shell scripts or you have any automation framework which needs to provide various kinds of notification like text messages or email notifications or even like app push notifications. Other services which we have seen customers who are trying to reinvent their Oracle workloads are like on analytics space where they leverage Amazon QuickSight, which can provide business intelligent BI reports based on your data in your Oracle workloads, and your AWS data pipeline, which can replicate data from your Oracle databases to your S3 or your data lake or any of other services such as RDS or Redshift. We have also seen a lot of customers moving to machine learning phase. We have Amazon Elastic Inference and Amazon Forecast and Amazon Lex, which are quite popular with data warehouse workloads running on VMware Cloud on AWS. to walk you through a simple how this integration works. On your left side, you could see AWS Cloud. On your right side, we have VMware Cloud on AWS. And if you have a database running on VMware Cloud on AWS, whether it's an Oracle rack or a single node database, and you are quite used to like taking RMAN backups through scripts or through like services such as Oracle Enterprise Manager jobs or a Puppet or Chef or even like third-party solutions, you could see you could actually run your AWS storage gateway in your connected VPC. The AWS storage gateway is just a managed EC2 service, which when you start up, okay, you point to the right S3 bucket, and this S3 bucket is outside of VPC because it's a region level service. And to have a secure communication between your storage gateway and your S3 bucket, we have an S3 endpoint, okay, which handles all the secure communication so that all the traffic gets routed internally instead of going through the internet. And the bridge between your VPC on your AWS side and VMware Cloud on AWS, we have something called as cross-account ENI, which is a high bandwidth, low latency connection between your VMware Cloud on AWS and your AWS Cloud. Using cross-account ENI, okay, we mount that AWS storage gateway S3 bucket endpoint as an NFS endpoint on your database virtual machine. So none of your scripts needs to go through any kind of changes, even when you're like leveraging native AWS services such as S3. So you can run your scripts if you're running scripts through cron or Enterprise Manager. Okay, it remains the same. Your RMAN backups could be taken, and the files could be like placed on this S3 NFS bucket. So your incremental backups, your level 0, level 1 backups will work. Same as if you are having a practice of merging your RMAN backups, that will also work. So this particular architecture gives you how easy it is to integrate any of your native AWS services with any of your workloads running on your VMware Cloud on AWS, which could be like a database, WebLogic, or even any of your business critical applications. And with that, okay, I will hand over to Andrew.
Thanks, Jay, for that. Thanks, Jay, for that excellent deep dive on the native AWS services there. So some final thoughts before we get to Q&A. You know, VMware Cloud on AWS is really the fast path to the cloud for your Oracle, and in this case, as well as your Microsoft workloads too. It's a very low risk lift and shift migration. Essentially, this is just a vMotion from your data center into VMware Cloud on AWS on top of our proven compute network and storage stacks, as well as the global AWS infrastructure. And again, you know, as Jay was talking about, you get access to over 160 native AWS services that you don't have in your data center today. So, you know, if you want to learn more about VMware Cloud on AWS, we have a number of URLs, and you can also follow us on Twitter and look at a variety of videos. As far as next steps are concerned, you want to talk to an expert, you can hit the URL at our Getting Started site, or if you want to look at your potential savings for your Oracle workloads on VMware Cloud on AWS, we have multiple sizers and TCO calculators that you can use. And if you want to go all in and take a test ride, we have a great hands-on lab that you can use as well. So with that, I think we're going to move to Q&A now. So let's take a look at what's in the window there. So our first question was from Darren Livingston. While the solution work with R5, EBS option for storage. Jay, looks like you answered that one, that it will work on R5 EBS. Bharath had asked, what's the best use case for DR from on-prem to VMC? Is it using vMotion or Oracle Data Guard? Sudhir, looks like you picked that one up, depending on the customer, what the customer has in the SLA. What else do we have here? Ramesh asked about the diagram. Sudhir, you picked that one up around the use cases. Since there are no other questions, we'll be publishing the deck for this as well after the presentation. I'd like to thank Sudhir and Jay for co-presenting with me today, and hope everyone has a great day, and thank you for joining.
Thank you.